This conference will now be recorded.
Hi, welcome back. Yesterday we discussed, we installed Jenkins master and then we installed Jenkins slaves into the Kubernetes cluster. We created a Jenkins slaves namespace and we created one user and we configured that user in Jenkins master and we are able to spin up the slaves as Kubernetes pods. And then later we created another Jenkins slave where we've installed Docker and we spin up the Jenkins slaves as Docker containers as well. So the steps I will note down here for clarity. If it is Kubernetes cluster, so generally what we do is create a namespace for Jenkins slaves. Okay, create a user that have access to Jenkins slaves namespace. Okay, and then later create kubeconfig file for Jenkins user, and then later configure kubeconfig in Jenkins master. So this is like kubeconfig will get all Kubernetes details. Test connection will be success if everything is good. So Kubernetes connection is success. Now we need to give pod configuration. Okay, so later we gave the image name and labels and Jenkins URL as a environment variable. Okay, so that's all we gave. So now what happens when we give this information? First Jenkins master authenticate to K8 cluster using kubeconfig. Okay, you know this already. We already saw how authentication and authorization will do. And authorization. Okay, then we since it have Jenkins slaves namespace, it will get the access. And after that, what will happen? Jenkins master request to spin up the pod by providing pod configuration details. Okay, now K8 cluster will pull the image and spin up the pod. Jenkins slave image connects to Jenkins master to download agent jar file. Okay, once it downloads, then Jenkins slaves will connect. Execution. And after that, now both are connected. Master will ask to execute the pipeline. So these are the steps will happen in the background. Okay, Fanning, is it clear?
Yeah, yes,
So these steps will happen. For Docker, mostly same. Okay, if we see here in Jenkins master also, we can see that information. This is the pod configuration sent by Jenkins master to Kubernetes cluster. Okay.
Yeah, okay.
And then Docker. The steps are same. We install Docker, we install. No. So for this, the plugin is Kubernetes plugin, and here it is plugin is Docker plugin. And after that, we
So, it-
configure.
so
Yeah,
it
yeah.
means in the master server, we need to install the Kubernetes plugin, and whereas in the slaves, we need to install the Docker. Am I correct?
This is for Kubernetes. Plugin is just to provide the Kubernetes. You need that dashboard right inside the configure clouds. If you want Kubernetes option, you need to install Kubernetes plugin.
Okay.
So there is nothing related to Docker here.
Haha,
Here I'm here. This is Docker VM.
oh,
We enable remote API in Docker VM. Okay. Remote API, you saw that yesterday. We can change the where some script. There we will enable 0.0.0 and one port. Okay, we enable remote API. So we configure Docker VM details in Jenkins master. And after that, you can test connection here. Means master is able to connect to Docker VM. Okay, and then we will provide image details, slave image details. Then when you run the job, master will connect to Docker VM and send the container configuration like image. Docker. So by default, Jenkins will send the Jenkins URL also. Now Docker VM downloads the image, creates the pod, creates the container. You should not say pod here. Creates the container, downloads the agent jar file, connect to master, then master will send job steps. Okay, these are the steps happening in the background. So yesterday we saw that already. When you stop and start the EC2 instances again, your IP address will change. Make sure you change those details in this configuration. Okay, when your IP address changes, you need to give those details here. So yesterday IP address got changed today. So I gave the new IP address. So
so
till now
this
we
concept
yeah,
for this
yeah,
configuration, can't we use the private IP?
no public IP.
Okay, okay.
Either private or public, that is based on our network configuration. If it is your company, you can do using private IP if both instances are in same VPC subnet. If in different VPC, you can have VPC peering. So a lot of network configurations based on your
Ah,
company or project architecture.
oh, okay, okay.
So yesterday we installed Maven on top of Jenkins slave latest. So this is the minimum Jenkins slave, and on top of it, whatever commands you want, you can install. But at the end, the user should be Jenkins. Otherwise, your slave will not connect. Okay, that is the requirement from Jenkins. Now we want to run Docker inside this. Now let us install Docker, and we will face some problems. Then we will see what is that problem. Okay, so yesterday we installed Docker through by default. A script will be there from Docker. The script will get your OS information, and then it will install Docker automatically. So Docker client only. Okay, so you cannot install Docker engine or Docker daemon again in Docker container. Okay, so we will mount that socket, host socket, that we will see now what is the problem will come. Okay, so this is Docker. Then Docker build -t Tucky trainers Docker -slave. I'm giving it as v3. Sorry, it is JNLP slave actually. JNLP slave. Okay, in this job, let me configure it to run Docker command. I'm asking to sleep for 300 seconds so that I will log into that. I'll take the shell access of the container and then I will check. Okay. Now push this. And use this image in your slave. Okay, pushed. Now let us run this. Okay, now it is in sleep for 300 seconds. We can see here it just pinned up. Let us log inside and then check whether we have the access to Docker or not. Okay, user is Jenkins. Now if you type Docker, you are getting this, but Docker PS and Docker images you will not get. Okay, you can see cannot connect to the Docker daemon. Okay, now let us configure that. Container settings. Here there will be mounts. Okay, so to get that syntax, let us go that official documentation. Syntax here is type equal to this one. Type and then source and then target. Okay, let us check more here. Bind mounts a directory or file from the host into the container. Okay, so this is the one we want. If it is type equal to bind, then src is required, and then after src, destination of your container, some path in container destination. Okay, so the exact syntax type equal to bind, that is confirm. After that, it is it comma or pipe? I didn't give any example here. If we gave example here, is it comma? Think comma. src var run docker.sock. Okay, that is the path of Docker daemon. You can check that here, var run docker.sock. And destination is bind type of mount. What is it? You can use any of this. Okay, I'm using just destination or tst. tst equal to same var run docker.sock. Okay, I'm binding the host Docker daemon to the container so that it will get access and do some Docker things. Okay. Now run this again. Docker exec -it. Okay, again same, but this time some different. It is able to connect, but still got the permission denied. So by default, Docker will give access to the root user. It will not give access to the Jenkins user. So what we have to do is, all this already by installing Docker, run user mod -a-g, adding Jenkins to the Docker group. Okay. So we do this now. And then edit it. To the Docker build and then push it. Cancel. Okay, now let us see Docker exec -it. Docker yes. Still there is a problem. Now the problem is little different. We did all the mandatory things. Now the problem is, let us see the group information of Docker here. Okay, get group info Linux command. What is a command? Get ent group and then group name, I think. Yeah, get ent group. So now I will just get ent, get entries, it means group Docker. The group name is 999 there. And then if you exit, now inside Docker host, now if you run this command, get ent group Docker, now the group name is 992 here. So that is where the problem is clashed between the Docker container Docker group name and host Docker group name. Okay, these two should be same. So you need to modify these things while creating the slave. Okay, now the host thing is 992. You should give the same ID while creating the Docker group here. Okay, so for that, let us see how to change group ID in Linux. There will be some command to change the group ID. Okay, group mod -g. What is the group ID you want, and then give it to the Docker. Okay, after installation, I'm running this group mod -g. We need to give the host 992, I92 to Docker. Okay. Now if you run this, foo, where is foo? Oh shit, here it is Docker. Here this is Jenkins. This is 992. This is Docker group. Okay. Now built, and then let us push. Now let us use here the Docker command. Slow. Now I am giving here Docker images, Docker PS. Okay, now you can see you got the access. Docker images also you got the access. Now let us build our cart image, some image inside this. Docker build -t cart :v1. You can see our code is downloaded, and then it started building. So any doubts still here? Gopi, are you clear?
Yes, sure. The process is okay. Yeah, no confusion in the process.
Yeah, okay. So same things you have to try in your project if you want to try the dynamic slaves. Okay.
Oh,
Mm, after this, so we have created the namespace in normal Kubernetes cluster like Minikube. We can treat it as on-premise or normal cluster, and we authenticated. But EKS, if you want to try, authentication in EKS is little different. Okay, so for that we need to have cluster now. We don't have EKS ready. It will take again 20 minutes. Okay, so we can discuss the authentication anyhow. By tomorrow I will make the cluster ready before the class, and then I will show you how it is little different, but the documentation is clear from the AWS. Okay, in normal Kubernetes cluster, so we will pass the user key and then the certificate file. But when it comes to the EKS, the authentication is not through the key and certificate, that is through the IAM user. So since EKS is in AWS, AWS has powerful IAM mechanism, user mechanism. AWS uses that mechanism to authenticate, but authorization is like role and role binding, same, it will follow the Kubernetes. That's what this diagram shows. Whenever you authenticate to the EKS cluster, like if you are a EKS administrator and you want to give access to me as developer, first you need to create IAM user. Okay, that IAM user will have some secret key and access key. Okay, if I am the user, I need to have the AWS command line installed wherever I run it, and then whenever I create that configuration file kubeconfig, first it will get those credentials like secret key and access key, pass them to the EKS, and there it will authenticate with IAM. If it is proper, then it will do the authorization and give the response. Okay, so the difference is very simple. If it is normal K8, user will pass key and cert. K8 will authenticate and against this and fetch role and role binding for authorization. Okay, this is the normal. For AWS EKS admin will create IAM user and share access key and secret key to user. Now user will have AWS command line. He will configure using AWS configure command. Okay, now this will be done, and after that he will create kubeconfig file. So inside that kubeconfig file there will be no key and CRT. When you run some kubectl command, first get the access key and secret key and pass it to EKS. Then EKS will authenticate against IAM. If success, then it will check role and role binding. So this is the overall concept. The steps are clearly mentioned here. So we can try this in tomorrow's session. So by this, with this, we can complete Kubernetes role-based access control. Okay, and I will follow these steps only, and we can move to the next concepts like pod logs, Elasticsearch. Okay, you know Elasticsearch is like a database holding log information mostly in our projects. Generally, if it is a server and if it is Elasticsearch cluster, then server will push the logs to the Elasticsearch. Okay, but we have pods. Pods will be spinning up, and then those will be automatically deleted by default, right? That is purely dynamic. Suppose if you want to see the logs of some killed pod, you cannot check it again. Or if you want to see the logs of existing pods, it is somewhat difficult. You need to log into the Kubernetes cluster or some command line or kubectl logs. You will not get the full information of the logs. Only the last few lines only you will get. So for that purpose, we need to push the logs of the pods to the Elasticsearch cluster. Okay, this is pod, and this pod will push the logs to Elasticsearch cluster. Okay, how it will push is there is something called sidecar. That is like Fluentd or Filebeat, something like that. This is also a lightweight container along with the pod. Okay, these two will be in single unit. Okay, so this pod will be writing the logs, and this Fluentd will be collecting those logs and then pushing it to the Elasticsearch cluster. So this pattern is called sidecar pattern. Okay, this is the main application. Application is generating logs and storing it to some path, and this Fluentd will refer that path, and then, for example, this is the path inside the container. Okay, let me close this. Okay, pod is writing the logs to some specific path. Fluentd will also refer to that path and fetch the log and push to the Elasticsearch cluster. So this is what we need to learn. How can you spin up Fluentd container as a sidecar pattern, and that will get the logs and then push to the Elasticsearch cluster. So if you want to give access to see the logs to developers, so developers will not get the pod shell access or nothing. They will go to the Elasticsearch cluster and they can see the pod logs there. Okay, so that is the best thing, and you can keep the logs for 14 days or 1 month, whatever. Now we need to install Elasticsearch cluster. So we have multiple options. So one option is get a VM and install Elasticsearch cluster in it. Okay. And the second option is use AWS Elasticsearch service, since we are already in AWS. And the third option is deploy Elasticsearch cluster in Kubernetes cluster itself. Okay, so these two are, this is somewhat a difficult process. You need to procure VM, install Elasticsearch, and then you need to continuously maintain it for upgrades, a lot of configurations. And this one is good option if your services are all in already AWS, and this gives us more cost, okay, from the AWS side. And anyhow, we are learning Docker and Kubernetes. We will see this option. We will deploy Elasticsearch cluster inside our Kubernetes itself. Then we will ask all our pods to send the log information to our Elasticsearch cluster. So we will go with third option. We will deploy Elasticsearch cluster in our EKS cluster itself. And then how can you send the logs? This is one option. And the other option is, daemon set. Okay, suppose this is your Kubernetes cluster and node 1, node 2, and then node 3. So daemon set will spin up one pod. We saw that example already. It will spin up one pod in each and every node. And we can ask this pod, fluentd pod, to push logs to our EKS cluster. Sorry, this is Elasticsearch cluster. So this is one option. You provision daemon set that will spin up one pod in each and every node. This will collect the logs of all the pods running inside this. Suppose this may be running 100 or 200 pods. This fluentd will collect all those logs and then push it to the Elasticsearch cluster. This is a huge data. So this single pod need to collect hundreds of pods logs and then push it to the Elasticsearch cluster. So this is obviously not a much preferred way. So the preferred way is this one. You create sidecar and then push the logs to the Elasticsearch cluster. Okay, we can see both ways, and but this is the preferred, and developers also like this way, so we will go with this way. Okay. Yeah. And how we deploy Elasticsearch cluster in Kubernetes? Now we will see. So everything is like, there will be Elasticsearch image. Configure a deployment. Configure a service and access it. So this is the normal process actually, but this is also not preferred here, and there is something called CRT or operators, custom resource definition. Here deployment is one of the kind, and service is one kind, and you have pod is another kind. Similarly, config map. Okay, we have many kinds like this in Kubernetes, but what if I have my own kind, like cart. So when I'm writing Kubernetes manifest itself, I want to mention API version is v1 and kind is cart. I want to mention like this. So to do that, Kubernetes will allow you. These are the reserved and the default things. These are like custom operators. You can define your own operators. Okay, further you need to develop something. So in this method, Elasticsearch created a CRD called Elasticsearch itself. Okay, now if you write API version v1 and then kind Elasticsearch, you will simply get Elasticsearch cluster within minutes. You don't need to write all these things. Okay, this is called as custom resource definition or operators. So we can go and use this Elasticsearch operator method and we can create the cluster. This also will work, but this needs a lot of this needs a lot of, you need to create config map, secrets, many things. So those are all the things handled by this Elasticsearch operator. It will create it all these things automatically with proper values. If you do this manually, we may miss something. But if you do this with this, then all the default things it will create and still we can customize this. Okay. So we can see this concept in from the next class, and we will move to the Helm charts and some other advanced Kubernetes concepts. How can you create your own operator, all those things. Okay, any doubts?
Shiva, sometimes they use monitoring tools like Datadog or those kind of things. So they'll monitor logs there also. So how can we do that?
Yeah, so we can use like Prometheus, and we can push those metrics also to Elasticsearch. We will do that. We will do that also. So right now we are pushing logs, right?
Yes.
Now we are pushing logs to Elasticsearch. Similarly, we will push metrics.
Okay.
And you can configure Grafana to read metrics. Like we have many nodes. If you want to see how many pods in this node, how many pods in this node, how many pods in this node, we can pull the metrics from here with Prometheus exporters and push it to the Elasticsearch, configure Grafana to read it, and then you can create the dashboards. Similarly, it can pull this node information, this node information, this node information. Whenever all the nodes, sometimes the Kubernetes cluster, all the nodes will become full busy. You don't have capacity, then you can get the alerts in that. And very advanced thing, you can even configure auto scaling for these nodes. If all these three nodes are busy and fully loaded, AWS auto scaling can create another node automatically and join to the EKS cluster. Okay, so that concept also we can see. Just remind me after we complete our advanced concepts. So many concepts are there. So till now we have seen the Kubernetes basics and basics like how you write deployments, service, config map, secret, stateful set. All those things are like that, like you configure the manifest or application. Now operations is important. Operations, once your application is running, I want logs to be collected. I want metrics to be collected. If my pod got too much traffic suddenly, replicas should be created automatically. Okay, so you don't need to go and increase the replicas. This is called as horizontal pod auto scaling. Okay, if my nodes are busy, are fully loaded, I want another node automatically created and join EKS cluster. These are the operations, like once your application is running, these are the things you need to handle in an automatic way. So we are going to see all these things as advanced concepts. Okay. Any doubts?
No, no, sir.
Okay, then. That's all for today. We can end this session and we can see in tomorrow's session. Okay, have a nice day. See you.
In case. Bye.
Bye.